For this example, what you're going to do, what you always do, is just plug in first. So if I take x is approaching infinity, I'm going to get infinity times, and then I need to know what the natural log of infinity is. Well, here's the graph of your natural logarithmic function. As you go to the right, the graph continues up. So this is infinity times infinity. And the only reason I'm pointing out this example is because sometimes people over-apply L'Hopital's rule. Well, infinity times infinity is not an indeterminate form. It actually just equals infinity, and you're done with the problem. So don't over-apply things. Stop and think about it for a minute. Know which forms are indeterminate and which are not. Now, I do want to note here that if you have an x sitting off to the side and algebraically you need to turn something into a fraction, it's not that hard. Like, say you got a 0 over infinity or something like that, and you need to work with L'Hopital's. So what you can do, and there's, again, no reason on this problem, but maybe there is on another, is actually say that this is the natural log of x divided by a 1 over x. Because you know when you divide by a fraction, you multiply by the reciprocal. So this and this are equivalent. Okay, another L'Hopital example. You take the limit as x approaches, and we're going to do infinity for this one, of 1 plus 2 over x raised to the x. So this is an interesting indeterminate form. So you have 1 plus 2 divided by infinity goes to 0. Remember that this 1 is not really a 1. It's a really small number, like tiny, I'm sorry, not a really small number, but really, really, really close to 1. And then this is raised to the infinity. Well, this is one of your indeterminate forms. So we do need to do L'Hopital's, but it gets a little complicated because I need to turn it into 0 over 0 or infinity over infinity. And what that means to me is I have to get this x out of the exponent. I need to turn it into a fraction. So one way to do that is to take the natural log of both sides, but I only have one side. So the very next step is you really want a natural log in there, so you're going to put one in there. So I'm going to say y equals. And what I'm doing is turning this expression into an equation. So I have y equals the limit as x approaches infinity of 1 plus 2 over x raised to the x. And what that lets me do is I'm actually going to end up solving for y. I'm going to do some work with it, but I need to remember solve for y at the very end. Make sure I'm back to y equals, because that's what I'm trying to get to. Well, I want to bring this x down. So now that I have two sides of an equation, I can take the natural log of both sides. So the natural log of y equals, and I'm going to have the limit as x approaches infinity of the natural log of 1 plus 2 over x raised to the x. And that is going to let me take this x and bring it up front. So the natural log of y equals the limit as x approaches infinity of x times the natural log of 1 plus 2 over x. And if I look at what I have right now, if I plug in infinity, I have an infinity times 2 over infinity goes to 0, so the natural log of 1. I have infinity times 0. That is still an indeterminate form, but not the one I want. So what we're going to do is take the process we did up here and apply it down here. I need to turn this into a fraction. So I'm going to take this x and move it into the denominator as a 1 over x. So I have the natural log of y equals the limit as x approaches infinity of the natural log of 1 plus 2 over x over a 1 over x. So what this equals now, if I plug in infinity, I know I have the natural log of 1 is 0, 1 over infinity is 0, so this is 0 over 0. I can actually apply L'Hopital's now, so I'm going to do the derivative over the derivative. So to do that, so still the natural log of y equals the limit as x approaches infinity, and then we know the derivative of the natural log of some u is u prime over u. Now the derivative of 1 is 0. This 2 over x could be rewritten as 2x to the negative 1. So when I take the derivative of it, it'll be a negative 2x to the negative 2. That's my u prime over my u, 1 plus 2 over x, divided by this is an x to the negative 1. So the derivative of that is a negative x to the negative 2. So I would rewrite all of this before I'd actually work with it too much. So I'm going to say that this is equal to the limit as x approaches infinity, and then I'm going to have a negative 2 divided by x squared over a 1 plus 2 over x over a negative 1 over x squared. And there's all different kinds of approaches to take here. What I'm going to do is actually divide by this fraction, which means multiply by the reciprocal. I'm going to bring it up as a negative x squared over 1. Bring it up there and work on simplifying this. So I'll rewrite this on the next page. Okay. So what we have is the limit. We have the natural log of y equals the limit as x approaches infinity of a negative 2 over x squared over 1 plus 2 over x, and we're multiplying that by a negative x squared over 1. So when we do that, this will be the limit as x approaches infinity. Negative times a negative is a positive. My x squareds cancel out, so this is just a negative 2, which is much nicer. Multiplied by 1, that's a 1 plus 2 over x. So now when I take my limit, I will just have a negative 2 in the numerator, and in the denominator I have 1 plus, and then if you look at this, we have, a positive 2. Negative times a negative is positive. So 2 over infinity is 0. This is just a 1 plus 0. So I know that the natural log of y equals 2 over 1, which is just 2. Now I've had students stop there before, but remember our goal was to get y equals. We set y original to the actual limit we wanted. So I want to figure out what y is. So I have one more step, and I'm going to change forms. This is base e. So I know that y equals e squared, and the answer to my original limit was e squared. So that brings up an interesting note. Notice where the 2 is here. It's right there. So the limit definition for e is it's the limit as x approaches infinity of 1 plus 1 over x to the x. That is the definition for e. Well, we just said that if you had the limit as x approaches infinity of 1 plus 2 over x to the x, that is actually equal to e squared. And it's true that if this is the limit as x approaches infinity of 1 plus, let's say it was 5 over x, you're going to work the algebra the same way and the calculus the same way. This will be e to the 5th. So if you know that, it's a nice little guide to get you where you want quickly. And those are very different examples for how to apply L'Hopital's rule.